So our next method here is called the principle of square roots. And so when we have an equation like a squared equals b, we can square root things and to get down to our variable. And so it's important to remember here that every positive real number has two square roots. It has a positive root and a negative root. If we take, and I know, for example, if I know x squared equals 4, well, what could x be? Well, x could be 2 because 2 squared equals 4. Or x could be negative 2 because negative 2 squared is 4. Negative 2 times negative 2. So we get the positive square root of b or the negative square root of b if we have this kind of equation here. All right, so keeping that in mind, here we want to solve this equation. Now notice this is a fairly simple looking equation. There is no x term. That's the key. There's an x squared, but there's no term that says like 5x or 2x or 3x. So what we're going to do is we want to use that square root idea. So now we want to get that x squared all by itself. That's important. We want to get rid of that exponent because we know the opposite of squaring is square root. So we square root both sides and we get the square root of x squared is x. The square root of 16 is 4. Or it could be negative 4. All right? So there's two answers because 4 squared is 16 and negative 4 squared is 16. Now, there's a little shortcut that we'll use sometimes. And that'll be, we can write that as plus minus 4. All right? So sometimes that's acceptable. If you're answering a question on a computer, sometimes you might need to write it out. But sometimes it's acceptable when we're just writing things to write plus minus 4. This means we have two answers, a positive 4 and a negative 4. All right? What if we have this equation? Well, we want to get rid of that squared. All right. We want to square root, but don't square root. If there's anything multiplied by here, we got to get rid of that stuff first. We want to isolate the square root or the x squared first. So isolate x squared. And we get x squared equals 20. Now we can square root both sides. And so x is the square root of 20. Or we have the negative square root of 20 as well. Now we need to simplify that. So we're going to break down the square root of 20. The square root of 4 times the square root of 5. And that gives us 2 square root of 5. So x equals 2 square root of 5, or x equals negative 2 square root of 5. We can write that as one term if we want to do plus minus 2 square root of 5. So again, the plus minus the shorthand version. You have to separate it there on a computer when you enter it. All right, so the key thing to remember here is that this method only works when we have no x term. So notice there's no x term here. There's an x squared, no x term, no 5x or 3x or anything like that. Okay, so let's try a couple more out. We've got to get that x squared all by itself. So let's get that 4 out of there. Let's add 4 to both sides. That gives us 5x squared equals 4. Now we got to get that 5 out of there. Don't square root yet. Divide by 5. And we got x squared equals 4/5. Now we got the x squared by itself, so we can square root both sides. Want to get that x squared out of there. The opposite of squaring is square root. So how do we square root fractions? Well, we square root the top and we square root the bottom. And don't forget your plus minus. And we know how to do the square root of 4. That's easy enough. That's plus minus 2 there. And the square root of 5 we got on the bottom. We don't like to leave it there, so we got to rationalize the denominator. We don't like to keep that there, so let's multiply top and bottom by the square root of 5. And that's going to give us 2 square root of 5 on top and 5 on the bottom, because the square root of 5 times square root of 5 is the square root of 25. All right. That plus minus can be out in front or it can be up top. Either one is fine. All right. So same idea. All right. You might pause and try this if you'd like. See what you get and come back. Let's get rid of that 50. Subtract 50. 2x squared equals negative 50. Don't square root yet. Got to get that 2 out of there. Let's divide by 2, and we've got x squared equals negative 25. Now we're ready to square root. So we'll go ahead and we'll square root there. And that gives us x equals, now it's a negative, so remember, that gives us an I. So we're going to have the square root of 25 we know is 5. And because it's negative, we need to make it imaginary, I. But we still need to make it a plus or minus. So remember that negative makes it an I. And so we have plus or minus 5i. So an imaginary solution here. Okay? So we can get a rational number like we did over here. Or we can get an imaginary number like we just did on that last example. Okay? So this doesn't necessarily look the same, but because we got the parentheses here and the parentheses squared and got that 15 we got to get out of there. Don't go trying to square out this x minus 3. Okay, leave it alone. Get that 15 out of there. And we got negative 15. Now we got the squared all by itself. So we got something in the parentheses squared. So, think of it as we got one thing squared. Kind of like a few moments ago we had x squared. Well, this is x minus 3 squared. So we got to get rid of that squared there. So we're going to square root both sides. All right, we've got x minus 3. That just cancels out that squared there. And we got a negative, so it's going to be an I. And the square root of 15 we can't do anything with. And don't forget to make it plus or minus. Whoops, that's not supposed to be an equal sign there. That's a minus sign. Okay. Now let's get that 3 out of there, and we're almost done. Add 3 to both sides, so x equals, now we can write this as plus minus I root 15 plus 3, but we'd like to have the real part first. So 3 plus or minus I root 15. Okay. So that's the idea. All right, we can solve lots of equations this way if they don't have an x term. All right, so the key steps there, if we don't have an x term, isolate that quadratic term and make its coefficient 1. Like this one, we had to divide by 2. And then square root both sides, simplify the radical if you need to, like over here. And then check your solutions. Now, it gets a little tricky when we have imaginary numbers to check your solutions. You can. Usually just kind of check your work and you can know if you did it right or not. All right? So one more way that we can use the square root method is remembering this. Remember these special products. A plus b squared is a squared plus 2ab plus b squared. And a minus b squared, when we multiply that out, becomes a squared minus 2ab plus b squared. These things are special products, very important to memorize, all right? Very useful to memorize this and really actually important to understand, all right? So understand that when we write this out, multiply it, we're going to get this middle term, okay? Do not write this as a squared plus b squared. It is not a squared plus b squared, okay? So again, if you need convincing, then write it out. A times a squared. A times b, ab. B times a, ab. And b times b, b squared. So it's a squared plus 2ab plus b squared. Okay, so watch this. So let's investigate here. Is this in that form? If it was, then it'd be really nice. Is this something squared? Yes. The square root of x squared is x. Is this a perfect square? Yes, it's 4. Okay, so if we square root those, this is just checking. We're checking. Okay, checking to see if it's a perfect square. All right, so if that's our A and that's our B, then the question is this 2AB? What's 2 times 4 times x? Is it 8x? Yes. Okay, so it is a perfect square trinomial. So that means this can factor into x plus 4. So x and 4 give us our x and 4 here. All right, so this equation here is x plus 4 squared equals 20. So notice here we have an x squared and an x term. And a few minutes ago I said you can't use the square root method when you have an x term. Well, that's true. But if we can factor it into this special, if it's one of these special ones, we can factor it like this. And then we can square root both sides because I want to get rid of that squared. And we get x plus 4 equals plus or minus the square root of 20. We should simplify that square root of 20. And we get 2 square root of 5 like we did in a previous problem there. And finish it off by subtracting 4. And we've got x equals, we're going to write negative 4 plus or minus the square root of 25. Oh, no, I'm sorry, not the square root of 25. The square root of 2 square root of 5. All right. There it is. Now notice, by the way, instead of writing this minus, we like to put this first. We like that square root to come last. It's okay if you do put the minus 4 afterwards, but all right. You might want to pause this and try it if you like. We ask ourselves, is this a perfect square trinomial? Well, this is, square root of this is 3x. The square root of 16 is 4. Now we're going to ask ourselves, what's 2 times 3x times 4? Okay, is that equal to 24x? Yes, it is. So that means that these two are a and b. So it fits that a plus b squared. So we have 3x plus 4 squared. And I'm going to bring down the 169. That's a whole lot easier than using the AC method here. So if you have this trinomial and you notice this is a perfect square and this is a perfect square, then we can factor it like this. And now we can square root both sides. And we've got 3x plus 4 equals 13 plus or minus. Okay, now this one came out to be a nice, neat integer. This one was a radical. So I left this one as a plus minus because it had the square root, and in the end we couldn't do anything with it. So here, if you have a perfect square that square roots, then here you really should write it out into two forms, 13 or 3x plus 4 equals negative 13. All right, then we solve this up, just subtract 4 from both sides, and divide by 3, x equals 3. Here, subtract 4 from both sides, 3x equals negative 17, divide by 3, and we get x equals 17 thirds. So two answers, 3 or 17 thirds. All right, that's the idea there. All right, so again, if it's a perfect square trinomial, if we can recognize that it is, then we can factor it, and we can square root to get rid of that squared. All right, so watch out. And notice, by the way, we did not set this equal to 0. It just is a perfect square trinomial, so we worked with that. In the next method, we will we'll use this and we'll force this to be a perfect square, and that's called completing the square. But we'll leave that for the next time. So, all right. Hope that helps. Keep working hard and you'll get it.